Greetings and welcome to another session of in the elementary school. Please be mindful of the due dates in this course. Please submit your assignments as soon as possible. Now we're going to look at some other articles that discuss the current trends in math and the current thoughts of leading professors and educators and administrators in the field. Our first article, are we teaching the math kids need? Every child possesses vast mathematics potential, but for them to access it, we need to rethink how we teach math. Many students suffer with math anxiety. Our society harbors damaging ideas about their math ability. For example, you may hear people say, I am a math person or I'm not a math person. These are false notions because everybody can succeed in math. Make sure to check out the website, ucube.org. It's a math education site. And then the article discusses the viewpoint of a Stanford psychology professor wants to see the math curriculum modernized so it's more engaging, more inclusive, and more likely to prepare students for the workforce. Instead of using memorization and math drills, math should be more of an exploration. Furthermore, the Stanford professor contends that the way in which we teach math is an inequitable system that pushes kids out of the calculus track in sixth grade. The content is not up to date and not very engaging. Data science also needs to be taught as a course. What is the greatest piece of advice for an early math educator? That's to spend time trying to change your students' mindset about math. Many people, and I was told this in school, that girls can't do math. And I'm sure that teacher probably would have said minorities couldn't do math, but he knew better than that. Let children know that they can learn anything if they put their mind to it. Our next article, how can we improve math education in America? Help us count the ways. I hope you take a moment after I've shared the Google Slides to look at these articles. I provided the link in all of the different presentations. And of course, there is unequal access to higher level courses in many schools. Students are held back from advanced math that will help them to get a job in a STEM job or in some other related area. Decisions about who gets tracked into or out of these higher level courses are often based on race, and I'm gonna add socioeconomic status. There are also kids who could be successful in math, but the opportunities are not presented to them. The pandemic also caused holes and gaps from distance learning. Math fluency is just not there anymore. 2 out of 5 Black and Latino students surveyed that they have a passion for technology and engineering and wanted to go to college. But yet, Only 3% are enrolled in AP STEM classes. And there are also not many teachers of color that teach AP. Survey results also confirm that there's a lot of math anxiety. Some of it arises from the recent test scores during dismal middle school performance. Students who started middle school early in the pandemic lost a lot of ground than any other group, and they're still struggling. Fears that teachers are insufficiently trained in math, they have poor math skills that harm America's competitiveness and weaken our ability to fill critical jobs. And that was reflected in the survey as well. Please note, several readers noted that their families need more support than ever in overcoming their own math fears. More investment is needed in teacher training and development. Reducing math anxiety is essential. Highlighting the importance of basic arithmetic is also imperative. Students need strong foundations before advancing to more conceptual lessons. Learning in more detail about what effective math instruction looks like for preschoolers and kindergarten is essential. Understanding why subjects like algebra and calculus have become so important in college admissions and whether statistics or data science should matter more. Tracing how math instruction has changed throughout history. Analyzing how math instruction and students' performance changed after the introduction of the Common Core standards. Those were some very important points that were brought out in this article. And all groups aware that they aren't sufficiently qualified and experienced math teachers due to low pay and poor working conditions. And this is the most important question to me. Are there schools that replicate best practices of countries like Japan and Finland and demonstrate better outcomes? Because if we don't do some serious reform in our educational system, our students in America will not be able to compete with the Chinese, the Japanese, the Africans, and not even Latinos. Now we're going to take a moment to look at some various math lessons. And we want you to think about the strengths and weaknesses of the lesson. What would you take away? What improvements or changes can be made? What were the strategies they used to address your visual, auditory, tactile learners? What type of manipulatives were used? Did they incorporate other subject matters? Did they incorporate math and science? Is it a STEM-focused lesson? Is it a more teacher or student-focused lesson? Did they state the objective and the essential questions? Do they give an exit ticket or a review at the end of the lesson? These are all important components and best practices for all educators.
Hi, Joe.
Hi, Bob.
As you know, I'm Bob, the counting sheep. Can you help me with something I'm trying to count?
Of course. Let's work on it together.
I want to divide 1 by 2/3. To find the answer, I flip 2/3 and multiply it by 1. Ugh, but that kind of hurts my neck.
I bet it does. Do you know why that works?
Because it does?
Well, when you divide 1 by 2/3, you're actually finding out how many 2/3 are inside 1.
So I'm trying to count how many times 2/3 fits inside 1.
Yes, that's a great start. Now, let's look at the figure. Bob, what do you see in the figure?
I see 2 of 3 squares are shaded, so I see 2/3. I also see that 2/3 goes into 1 more than once and less than twice.
Yes, 2/3 goes into one time with some left over. And we'll think about filling that empty square with another of the 2/3. Let's make this one blue. And notice we can fill in that empty square with just one of the blue squares. 4. How many loose squares are there in total?
1, 2.
So we used one of 2, or half of the 2/3 to fit into the empty space.
Wait! Does that answer my question? How many times does 2/3 fit inside 1? It fits once, and the little bit left over is 1/2.
Exactly. Our answer is 1.5. That can also be written as 2/2 plus a half, or 3/2.
I'm Bob, the counting sheep, and I know how to count how many times 2/3 fits into 1.
We did it.
Yeah.
Remember, when you get stuck, think about the problem and draw a picture.
Even when you're Bob, the counting sheep.
Yes, and it's always good to remember that rules can be useful, but it's even better to understand why they work.
Yeah. Thank you, Joe.
You're welcome, Bob.
Here are some strategies in how to teach a number talk.
Okay, so we're going to try a different number talk this time, and this time it's with numbers, and it's going to be multiplication. Okay, so get ready to think, and the problem is and if your thumb is already up, you might try to see if you could see it a different way. Okay, so I'm seeing most people's thumbs. Is anybody willing to share what they think the answer might be? Okay, Joe, what do you think?
720.
Does anybody have another idea about what the answer might be? Okay, Shay?
725.
I changed my answer.
Hold on. Does anyone have a different idea about what the answer might be? Okay, so Joe, what's the matter?
I realized what I did. I think Shay and I probably both got to 750, but she accurately subtracted 25, and I subtracted 30 because I was confused by the rounding I was doing from 29 to 30.
That's good. That's good. So I'll have you actually. So you're saying that you want to disagree with this answer?
I want to disagree with my answer. Yes.
Okay, and so you're agreeing that the answer is 725.
Yes.
Okay, so let's go through your method then, Joe, and you can show us what you did wrong.
What I did was I rounded 29 to 30 to make a friendly
so we're doing
number.
25 times 29, but you decided to do 25 times 30 to... Because?
Because 30 is a friendly number and
Okay.
easier to multiply with.
All right.
And then what I did was I broke 25 up into 10 plus 10 plus 5. So what that does is you can multiply 30 by each of those numbers. So that turns into 300 plus 300 plus 150.
So you multiplied 30 times each one of those numbers,
Yes.
10 plus 10 plus 5. Okay, and then?
So 30 times 10 is 300, plus 30 times 10, which is 300, plus 30 times 5, which is 150.
Okay,
So I added those up, and that equals 750.
okay.
And then I knew, because I rounded 29 up to 30, I had to subtract a number. And I think I just got a little confused. Instead of subtracting the 25, which is what I'm really doing here, multiplying by an extra, adding an extra 25 in the multiplication.
How do you know you're adding an extra 25 in the multiplication?
Because I'm doing 25 times 30, which is 25 times 29 plus 25.
Ah, okay.
Yeah.
So you added too many 25s.
Yes, exactly.
And you want to take away one.
And I want to take away 25, which would
So
yield,
you got,
yeah,
and then you got,
that would be 725. But I accidentally did minus 30 in my
but you almost did.
confusion, and that would have.
That's
why
an
I got
interesting mistake,
720.
though. Minus 30.
Yes, it is an interesting
Where do you think the
mistake.
30? What were you thinking? Do you think you were?
I think
on
I just,
this?
yeah, I got confused, I think, about which number in the original equation I was adding an extra up.
Yeah, that's really complicated. Did anybody have the same? Did anybody else round up to 30? Oh, really? Okay. Do you want to talk about what you did? You don't, Geraldine. Who does want to talk about what they did? Okay. Joe, and then.
Yeah, similar to Joe, 25 times 30 was my first initial reaction to create two friendly numbers. But knowing there's ways in math that we kind of create shortcuts. So knowing that 30 makes it more too overwhelming for me to actually do it sometimes in my head. So I just cut the 0 off and made 25 times 3. So I made it into quarters almost. So 3 quarters.
Ah, so you were thinking 3/4.
Yeah, so that way, because I know in the future I will then add the 0, knowing that that rule applies to all equations multiplied by a 0 at the end.
So when you did 25 times 29, you did
The same thing, yeah, 25 times 30.
times 30, but then you were thinking of quarters.
Yeah, 25 times 3.
So were you thinking of 3 times 25? So you were thinking of 3/4?
Yeah, I mean 25 just rings, quarters in my head.
Okay, so 3/4, and you knew that was
75.
75.
Like cents almost, yeah.
And then,
So now I kind of did half the equation already, because knowing the rule, the 0 rule, when you multiply something by a 0, you just add on the 0.
When you
So, I just kind of did Jones' method, but instead of breaking it down and decompose it, I just try to simplify the equation and then apply the rule of 0.
okay, let me rewind you. I think I heard you say when you multiply by something by 0, you add a 0?
Yeah,
Is that what you meant?
anything you multiply, well, just knowing, anything by 10, 20, or 30, you can, cut the 0 off and just multiply by the 3 or 2 or 1, depending on the number it is. And then once you get that number, you just add on the 0 at the end.
Oh, so you weren't multiplying by 0. You were multiplying by
2, yes.
a multiple of 10.
Multiple of 10.
And,
So what I
okay.
guess what I'm trying to say is that I definitely broke it down so that
Okay.
I was applying by the tens.
Okay, so the 25 times 3, the 3/4, help you think about the 750.
Yeah, just to make it more friendly of an equation.
Okay, then that's what we're after. And so what did you do then?
Same realization that Joe had is that, because I round up, I am multiplying one more 25 than necessary. And so I'll subtract that 25 away from 750. So 750 minus 25, just so that, similar to Joe, it's similar to 25 times 30 minus 25.
Okay. It's very, very similar. Okay.
Yeah, very similar.
Who did it a completely different way? Okay. Vivian, you want to go?
I took 25 times 20. So I guess basically I took apart 29 and made it 20 and 9 first. And so I did 25 times 20.
Okay. So you multiplied 25.
Yes, and I did it kind of similar to Julio, in that I just took the 0 off with the rule of 10. So like I took it off and did 25 times 2 and I got 50.
Okay.
And then I added the 0 back that I'd taken away, so I got 500.
So if 25 times 2 is 50, then 25 times 20 is 500. Okay?
And then from there, I applied the quarter rule. So I knew that 4 would make 100. So I knew that
You knew that
9
4
425s.
25s would make 100?
Uh-huh.
Okay.
So 4 groups of 25, if you add them together, will make 100. So I saw that there were 2 groups of 4, so that was 200. So I had 700. 500 plus 200 is 700.
Okay. Rewind for a second. Where did you see the 2 groups of 4 quarters?
In the 9.
Ah, in the 9. So
Yeah.
when you broke up the 29, you broke it into, you were thinking about 29 as
20 and 9.
20 plus 9?
Mhm.
Okay.
And
you,
then I broke the 9 up into 4, 4. and
Ah,
9.
okay. So then you broke the 9 up into 4s? 4
4, 4, and 1.
plus 4 plus 1. Okay, now I'm up with you. Then what?
Yeah, and so I knew that each of the 4s would represent 100 because I was multiplying it by 25.
Ah.
So I knew 4 times 25 is 100, 4 times 25 is 100. That would make 200. So I added that 200 to the 500.
Okay. So this really represents for you 4 times 25. And this represents 4 times 25. And then the one?
25. I just added
25.
on to
1
the
times
700.
25. Okay. And so going back here then, this 9 actually means 9 times 25?
Yeah.
Okay. Whew. Okay, now what?
Well, as I said before, I took the 200 from the 4 times 25 plus 4 times 25. I added to the 500.
Okay, so you knew this was 100 and 100, so you knew that was 200. And you added that
To
to
the 500.
the 500 you had here. Okay, 500. Okay.
And that gave me 700.
Okay.
And then there was that 125 left.
Okay.
And that I added onto it, and I got 725.
Okay. How are we doing on time? We have us think about some of the properties we talked about. And so you've broken up numbers in a lot of different ways. And so I'm going to do is I'm going to draw a picture for what I think Joe saw first up here, a diagram. And if this is 25, Joe, you saw the 29, but then you added one more on there. So you multiplied 25 times 30, and then you subtracted the 25.
Yeah.
So this part went out, and this was 25 plus 1. Does anybody know what property that is? What Joe did? How you would write it algebraically? Talk to each other real quick. See how you would write this algebraically.
You'd be doing 25 times 29. Distributing the 25. You're subtracting the 25. Right, because you know that you added it.
Too bad we don't have the mics on every table. Is anybody willing to say what property it is and how it works?
We thought it was a distributive property.
Do you want to say why, Kellen?
Yeah, since Joe added 1,
Hang on, let me just write it up here.
he's now taking his 25 and multiplying it by both 29 and 1.
Okay, so how would you write that? Do you know?
25 times, and then with parentheses,
Okay.
29 plus 1.
29, which is the original problem, plus 1 that he added. Okay?
And he's distributing the 25 across.
25
both
times
29 and
1.
1.
20. Okay, good. What about one more? Let's see. Let's see. Julio used the 3/4. Joe, Vivian. How would you write Vivian's using the distributive property? Talk that one over. And draw on the desk. Like pretend with your finger how you would draw a picture for this.
Plus.
Or 20 plus 4 plus 4 plus 1.
Yeah, it's just
24. Is anybody willing that we haven't heard from yet to explain this for us? Stephanie, great, thank you.
So explaining what would be the equation, or
Yeah, well, you could do the picture or the equation, either one. We can do both separately if you'd like.
so first it would it would be 25, and then the 29 would be broken up to 20 plus 4 plus 4 plus 1.
So 20 from, oh, this is badly out of whack. It's more like that. 4 plus 4 plus 1. So you're saying that this is, oh well. Is that what you're saying, Stephanie? Okay. So this whole thing is still 29, but those are the separate pieces. Okay, then how would we write it algebraically? Somebody else? Okay, Erin, try.
I guess it would be 25 times.
I feel like I need a different colored pen somewhere. Okay, I'm going to write it over here then.
Okay.
So 25 times.
Times the quantity of 20 plus 4 plus 4 plus 1.
What do you think? Yep. Okay. Good. We are done with our number talk. Thank you very much. I'm sorry if everybody didn't get to talk. I tried to keep track, but boy, I felt so much more on the spot than I usually do when I'm doing stuff like this. Do we need to do it again, like a whole retake, Joe?
It's great. I think it's great.
You did? I got so confused with this though. And you know what? Actually what
it's not equal, but if that's one whole, and if these, let's say these two parts are shaded, then that's 2/3, right? Of that, and this one doesn't count now, so that's 2/3, and this is the other 1/3. And so if you draw, this is a whole. See, that's the whole, right? And if you take these two and put them here, like it was, and then you still have these, then you still have the 1/3 left, and 1/3 is half of 2/3, and so you just add 1/2, and that's what I was saying.
Now, remember what the day that we talked about, convince yourself, convince a friend, and convince a skeptic. Anybody want to, let's see if anybody can challenge Sam or push on his thinking a little bit.
Okay,
I thought you were.
okay, well that's exactly what I was thinking, and that's how I convinced our table, because we had a couple of people here who thought it was 6, but then I pretty much convinced him that
Zach or Ben, are you willing to talk about what Michael Lamb said that convinced you?
I thought it was everything 1.5 at the beginning. He was the skeptic.
You were the skeptic? Okay, now really, this would be really great. What made you change your mind?
It made more sense to me with that before.
Can you explain it? No?
I think so.
Okay, would you try please? Because if you can explain what somebody else said, then you're one notch further up in your ability to understand it.
Okay. Well, there's 2/3, and 2/3 goes into one whole time, and there's still a little half left over, or a little 1/3 left over, and so you try to fit it in there. All of it fits, only 1/2 of it fits, and so it's even 1 and 1/2 times.
Your child needs these.
Some people think I'm not good at math. I can never do anything. I'm not good at it. I'm just gonna give up.
A lot of people think of it as like prison, like you don't have any freedom.
Okay, time to go to your notebook. Okay, read chapter 1. Okay, here's your worksheet.
The math textbook is kind of like the Bible. You have to kind of worship the textbook, and I don't really like that.
Everybody's going so quickly, and I thought if I didn't go quick, people think I'm like not smart.
I made a lot of mistakes, and I got really sad about it.
You make a mistake, you're pretty much done. Yeah.
They can't do it fast, and they're so smart because they can, and I'm not smart, and I just kind of stopped.
You feel like you're serving a sentence for like nothing.
I love it. That does look like a cuboid.
Oh, we got it!
I've done better with math when I was talking with people, sharing ideas.
4 or 5 brains work better than 1.
I'll see it one way, but then someone else will see it another way, and I'll be like, oh my gosh, that makes so much sense.
I love that we're getting different answers out because lots of problems in math, there are different answers.
Have more than one way to solve the question.
Because in real life, you're not gonna just do one thing. You're gonna do many things. You're gonna need to use different methods. Yay!
No, hold on. Take your time and just experiment with every way that could possibly work.
You definitely have to be patient because certain problems, they take forever. Math isn't about speed, and you can make mistakes and you learn from them. Yeah, I did that too! Yes! Told you!
Math isn't like the enemy, and it can't hurt me.
You can run wild, you can pass ideas by each other.
I thought that math was all about right answers and wrong. Now that I believe that math is really about ideas and creativity, it's a lot more inspiring.
So what did you think about those different strategies that were presented and that you as a teacher can use number talk to help your students think about thinking and how they logically solved those problems and each step that they took in the order of operations or what was the justification of how they solved the problem? And I really like those activities where they were using the string or the yarn to make geometric shapes. You could also use toothpicks and marshmallows to make cubes, triangular prism, pyramids, and so forth. There are many different unique ways in which you can do hands-on activities to help your children to learn various mathematical concepts.
Hi Team Grade 4, my name is Miss Aaliyah Brewster and it's time for us to do Grade 4 Mathematics. But just in case you're not feeling motivated, remember the words of Paul Halmos. The only way to learn mathematics is to do mathematics. So what are you waiting for? Grab a pencil and a notebook, get settled, we're about to start. Today's topic is ordinals. Before we dive into ordinals, let's differentiate between cardinal numbers and ordinal numbers. You see, cardinal numbers give us the exact quantity of an object. In other words, cardinal numbers answer how many. For instance, the given picture shows 4 cars in a parking lot. Hence, 4, or F-O-U-R, is the cardinal number because it depicts the amount of cars in the parking lot. However, ordinal numbers are different. Why? Ordinal numbers tell us the position of an object rather than their quantity. For example, the given picture shows different floors in a building. We can use ordinal numbers to define the position of each floor. For example, the floor that is above the door would be the first, then there's second, third, fourth, fifth, sixth, seventh, eighth, ninth, and 10th. Moving on, we're going to look at another picture. This picture is depicting some athletes as they are competing in a 400-meter race. We can use the ordinal numbers to define their position within the race. Now, the person that is closest to the finishing line, that person's position would be first, followed by second, third, fourth, fifth, sixth, seventh, eighth, ninth, and 10th. Notice there is a major difference between cardinal numbers and ordinal numbers. The difference would be one talks about quantity while ordinal talks about position. Hence, the number is not only written as it is, but it has letters attached to it. And we're going to zoom in to the reason as to why letters are attached to the numbers. Okay, boys and girls, ordinal numbers are written and spelled differently than cardinal numbers. For example, first is written with the numeral 1 and ST, right? Even though it is written with the numeral 1, it is not spelled O-N-E as the cardinal number is usually spelled. First is spelled F-I-R-S-T, while second is written with the numeral 2 with N and D attached to it. And it is spelled not T-W-O, but it is spelled S-E-C-O-N-D. And the same goes on for third, fourth, fifth. But did you notice in the number fourth, or the position fourth, there is F-O-U-R and T-H. And that same TH is written next to the number if you were to write it with just the numeral. That's the way ordinal numbers work. Moving down, you'll notice 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th, 13th, 14th, 15th, 16th, 17th, 18th, 19th, 20th. And we can go on and on and on. Like cardinal numbers, ordinal numbers are infinite. To test to see if you understand ordinal numbers properly, we're going to do a quiz. That's right, it's quiz time. This quiz is very simple. Don't panic. What we're going to do, we're going to observe these pictures and look at them in their exact order. You would notice there's an image of a butterfly, a spider, a beetle, a fish, a starfish, and a seahorse. Now let's answer these questions. The first question is, if the butterfly is the first animal, which animal is in the 4th position? Which animal is in the 4th position? If you guess fish, then you're correct. The fish is in the 4th position in the sequence. Moving on, question 2. What place is the starfish in? What place is the starfish in? Well, the starfish is in the 5th position, and we spell fifth F-I-F-T-H, or we can write it with the numeral 5 and TH at the end. Question 3. What place is the spider in? What place is the spider in? Well, boys and girls, the spider is in the 2nd place. We can spell out the word second, S-E-C-O-N-D, or we can write it with the numeral 2 and N-D at the end. Now, the 4th question. Which animal is third? Which animal is third? Now, this question is not asking us about position. It is asking us which animal is in a certain position. So, the correct answer there would be the beetle. The beetle is in the 3rd position. The final question for this quiz now. Which animal is in the last position? Which animal is in the last position? The answer for that would be the seahorse. The seahorse is in the last position. Now let's move on to complete a table. For this activity, we're asked to either write the ordinal numbers in its numerical form or to spell out the name. Okay, so for the first one, it was done for you. So on one side, we have 1, the numeral 1, and ST. Now 1 and ST symbolize first, and first is spelled F-I-R-S-T. However, you have to tell me the numerical format for third and 5th. And when you're finished with that, you're going to spell out the name for 7th and 10th, and then you're going to write the numerical form for the 20th and 21st. And finally, you're going to spell out the name for the 24th. Were you able to get it correct? Let's verify. So we were tasked with completing the table, either writing the ordinal number in its numerical form or spelling out the name. So the first one was done for us. We have the numeral 1 with ST, which symbolizes first, and first is spelled F-I-R-S-T. However, you were tasked with identifying the numerical form for third and 5th. How do we write third? We write third by writing the numeral 3 and then including RD at the end. Very important. How do we write 5th? We write 5th by writing the numeral 5 and including TH at the end. Extremely important, because if you do not write the letters at the end, okay, there is no telling the difference between ordinal and cardinal. Okay, so it's very important for us to write that letter at the end if we're talking about position. When you're writing ordinal numbers, it is very important for you to write the numeral and the letters at the end. If you fail to do this, there's no differentiating between cardinal numbers and ordinal numbers. If you just write numeral 5 and say that that's fifth, you would confuse the examiner. So it's important when you're writing ordinal numbers and talking about position that you write the numeral and the letters attached to it. Moving on now to complete our table, our next task was to write the spelling for 7th and 10th. First, how do we spell 7th? We spell S-E-V-E-N, 7, and T-H at the end for 7th. 10th, we write T-E-N and we add a T-H at the end of that and we have 10th. Now, next we were asked to identify the numerical form for the ordinals 20th and 21st. How do we write 20th? We write the numeral 20 and we add TH at the end. However, when we're writing the 21st, we write the numeral 21 and we add ST at the end of it. Okay? Now moving on to the final one, we were tasked with writing the spelling for the 24th. So we spell the word 20, which is T-W-E-N-T-Y, and then we write fourth, F-O-U-R-T-H, 24th. Good. Let's move on to our final activity. For this activity, we're going to look at the days of the week. That's right, the days of the week. Now, boys and girls, can you tell me what the days of the week are? Okay, I'll help you. It is Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. Wonderful. That took me back to nursery school. Okay, continuing with ordinals. Our first question for this activity is, what is the first day of the week? Very simple. What is the first day of the week? Well, boys and girls, the first day of the week is Sunday, not Monday. Sunday is the first day of the week, okay? The second question, what is the position of Wednesday in the week? What is the position of Wednesday in the week? So if we're going to look at the days of the week chart, let's try to identify the position of Wednesday. So Sunday is the first, Monday would be the second, Tuesday would be the third day of the week, and Wednesday would be the fourth day of the week. Okay, now this final question, it's a brain teaser, but I know you'll get it correct. It says, starting at Saturday. Okay, so we're starting at Saturday, not Sunday. Starting at Saturday and moving backwards. Backwards, what would be the third day of the week? So if we're going to start from Saturday, we're going to move backwards. So remember when we're saying the days of the week, we start Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. But now we're moving backwards. So we're going Saturday, Friday, Thursday, Wednesday, Tuesday, Monday, Sunday, right? So starting at Saturday and moving backwards, what would the third day of the week be? So if Saturday is the first, then Friday would be the second, and Thursday would be the third. Therefore, the third day of the week, if we're starting from Saturday and moving backwards, would be Thursday. Okay, boys and girls, I trust that you would have enjoyed today's lesson. I sure enjoyed your company. But now it's time for us to go. Thank you for tuning in, and remember the words of Paul Halmos. The only way to
Hello boys and girls. Time for another lesson on our mathematics workshop. I'm your teacher, Ms. Shamsuddin, and today we will be learning about money. Now I'm sure you know what money is. Remember what Shakuntala Devi said, without mathematics, there's nothing you can do. Everything around you is mathematics. Everything around you is numbers. Now, what exactly is money? Like I know, I'm sure that you know, money is something we use to buy things that we need. We use it at the market, we use it at the supermarket, we use it to travel. So we can simply say that money is a medium of exchange. It allows people to obtain what they need to live. A very, very long time ago, people exchanged goods for other goods. They did not have that special commodity called money. This practice was referred to as bartering. Like gold and other precious metals, money has a lot of worth. So, in other words, we can say that money is a medium of exchange, a unit of account, and store of value. Now, do you know what money we use here in Guyana? I am sure you know that we spend dollars. Our money is more popularly called Guyanese dollars because there are other countries that use dollars, but the design of their currency is quite different. The Guyanese dollars comes in two forms. Do you know what they are? You're absolutely correct. We have notes and we have coins. Now, if you look carefully, you will see the specimens of our notes and the specimens of our coins. The symbol we use for Guyanese dollars or to express our money are the dollar sign. We could also use G and the dollar sign. We could use capital G, Y, the dollar sign, or we can use GUY and the dollar sign. And all of those stand for Guyana in short. The note values we have are the $20 note, $50, $100, $500, $1,000, and the $5,000 note. For the coins, we have $1, $5, and $10. So when writing Guyanese dollars or when writing our money amounts, we use the dollar symbol, which is the most popular way of writing money. Then we write the value. After that, we put a point, then 2 zeros. So for instance, here I have a $500 specimen. If you look on the note itself, you will see the dollar sign and $500. Do you see that? Yes. But if you do remember, I said there are some other ways that we can write these money amounts. For instance, for the $500, we can write G, the dollar sign, 500.00. We can also write GY, the dollar sign, 500.00. Or we could write GUY, the dollar sign, 500.00. Let's look at a few more examples on how we can express our money. Here I have the specimen of a $5,000 bill. For this, we could write the dollar sign and 5,000.00, or we could write G dollar sign 5,000.00, or we could write the G dollar sign 5,000.00, GUY, the dollar sign 5,000.00, or GUY 5,000.00. For our coin, remember this is also referred to as dollars, and this is the $5 coin. So for this, we could write the dollar sign 5.00, G dollar sign 5.00, GY, the dollar sign 5.00, or we could use GUY, the dollar sign 5.00.
Okay.
Some more of our Guyanese currency. Do you think you could write these on your own? I'm sure you can. The first one we have $1,000. Now remember, there are at least 4 ways that you could express this money. You can use the dollar sign, you can use G and the dollar sign, GY and the dollar sign, or you could use GUY and the dollar sign. So look carefully and see if you would have expressed all of these amounts correctly. Now, it is important to note that in some countries, even though they have notes and coins, the coins do not always represent dollars like our Guyanese money. In some cases, the coins are used as cents value. In countries like the United States of America, their notes are represented as US dollar, and their coins represent various values in cents. So for the US money system, they have both dollars and cents, where their notes represent the dollars and their coins represent the cents. Now, when writing money amounts for the countries such as the United States, we write dollars, and after the point, we write the cents values. So for instance, we have $30.53, $30.53. Here you see, for the $30, we put the dollar sign in front, and for the cents amount, the denotation or the symbol for cents is written after the amount. Now, I am sure that you are very familiar with the point. Yes, that is the decimal point. And all it does is separate the dollar value from the cents value. So the 0.00 that we write at the end when we are expressing our Guyanese dollars or our Guyanese currency simply means that there is no cents values. Thus, we write 00 behind the point or the decimal place. Please remember that the dollars is on the left-hand side of the point and the cents is on the right. Even though we do not have the cents value in spending our Guyanese dollars, it is still important for us to know, since other currencies such as the US dollar and the EC dollars are used as foreign currency or exchange in our country. So let's try writing some of these amounts, as I call them. I hope you have your pencil and your book and you are ready to give it a try. Remember, when we are writing, we have to write dollars amount, the point, and the 00, which would represent the cents. So if I just say dollars, you automatically know that after the point, you just put 00. But if I give you both dollars and cents amount, you know that you will have to write that cents amount after the point. So here's your first one. $74.38. $74.38. Did you write this? If you did, you're absolutely correct. So $74.38 is written as the $74.38 and the cent symbol at the back. Listen for this next one and write $125.45. $125.45. Does the amount you wrote look like this? If it does, you're absolutely correct. So you're getting it. So we have the $sign 125, the point or the decimal place as we say, 45, and then the cent symbols. And for the last one that we will try, $1,500. $1,500 or $1,500. Did you write this one like this? You're absolutely getting good. So it's the $sign 1500, which is $1,500. We have the point and 00. Remember, I did not give you any cents value. I simply said $1,500. So, like I told you earlier, you still insert the point, but you write 00 to the back, which represents there is no cent value at the end of that amount. Well, that's it for our lesson on money for today. Let's do a simple recap. Money, we learned, is a medium of exchange. It allows people to obtain what they need to live. We also learned that a very, very long time ago, there was a system of bartering where people would exchange goods for another goods or services. The money we use in Guyana is referred to as dollars. And the symbols we use for our Guyanese dollars are the $sign, capital G and the $sign, GY and the $sign, or GUY and the $sign. We also learned that there are two forms of our money. We have notes and we have coins. The various money amounts used in the notes are the $20, $50, $100, $500, $1,000, and the $5,000. For the coins, we have $1, $5, and $10. There are some countries like the United States of America that has the dollars as well as cents amount. Their notes are used for the dollars and their coins are used for the cents. So there we had it. It's always a pleasure to have you on the mathematics workshop. Do join me another time.